So just your acid base?
Yeah, just go with
Alright.
all of that.
Let's see if we can help this. Okay. So we got CO2 plus what? H2O is equal to what?
H2CO3.
H2CO3, which is equal to what?
Hydrogen plus
HCS.
What's the hydrogen? Okay. Alright. So in our body we have a pH, right? And pH measures what? What does pH measure?
Hydrogens.
Amount of hydrogens, right? Or how acid something is, right? And so our body wants to stay where? Around 7.4, right? That's pretty much our normal. And so we look at this, we have to say, we use these guys right here, this is the buffer system. We use it to be able to control us to be 7.4. So where do you deal a lot with CO2? Your lungs. So this is your respiratory side. Right? And then HCO3 and hydrogen, a lot of this is controlled in the kidneys. And the kidneys do a lot of metabolizing, right? And so, or like in your small intestine tract and stuff like that. So it's more of has to do with metabolism. So this is going to be the metabolic side. Does that make sense? Okay. And so you just need to know that those guys come together to form this. And then they break down into this, and this breaks down into that, and then goes into that, okay? So you can just forget about that. Something important to understand for the concept we're trying to get here. So, so the next principle you need to know is that if this side of the equation goes up, then this has to go up, right? And so CO2, an increase in CO2 equals an increase in hydrogen ions, which equals a lower pH, which equals more acidity, right? So long story short, CO2 equals acid, right? So if you just can kind of get in your head and just kind of think, every time you think CO2, think of more acid, right? And so what is wrong with acid? If you have too much, obviously we have acid. What's wrong with too much acid?
Your enzymes don't function properly.
Yeah, it starts breaking down enzymes, breaks down proteins even. It's just if your body does not function well at these levels, right? And so imagine an acid is like a little kid with a hammer. He runs around this room and just starts smacking the walls really hard, you know? So it's just eating everything up. And so what do you have to do to stop the walls from getting eaten up? Stop the little kid, right? And so if I was a buffer, if I was a base is someone who accepts the acid. So a base comes up to the acid and he puts his arms around him, like bear hugs him super tight and stops him from swinging the hammer. So the kid's still here, right? The acid is still here, but it's not having its acid effects. And so what happens is it accepts the extra proton from hydrogen. So you have HCO3 and he's a base, right? And this guy is an acid. And we're trying to make a buffer, right? Which is this guy. And so we take him and he accepts him, right? And then he no longer has this guy, right? He's no longer that acid, he's neutral. He's neutralized. Does that make sense? And so that's why your HCO3, your bicarb, is going to be your base, and then your hydrogen ions, your acid. And so when we look at this person right here, this is his eyeball.
Oh.
Looks like Skeeter. Okay.
His neck just got longer.
Okay. And then we kind of come like this. Why you gotta hit? What's wrong with this dude? It's so sick. What? It's just genetics. Come on. Here,
stomach
Uh-huh.
and his throat.
Yeah.
Just genetics.
Yeah, it's perfect, right? And then. Okay. Okay, guys. Okay. So, so what's going on here? We have a person, right? We have a person, and what does he have going through him?
What?
A digestive tract, right?
I was like, what?
Did you tell what this is? Come on. It's the best drawing we've seen. Okay, so this comes in the esophagus and comes down to the stomach, right? This little C pouch, right? And so there's a little thing right here, a little muscle, circular muscle. It's called the pyloric right there. Goes into the duodenum, right? And so that kind of stops things from going down until they want to go down. And then past this, you go into your small intestines, your large intestines, and you come out. Okay. So, what cells in your stomach make acid?
Chief cells.
Parietal cells.
Dang it.
Parietal cells, right?
You should use
Parietal
those
cells
first.
have proton pumps in them. Remember the protons, right? Proton pumps. So they pump protons or acid into the stomach. And so what is acid good for?
It breaks down proteins.
It breaks down proteins, right? And so if we have acid in our stomach, it helps destroy bacteria, really. That's what we're using it for. It helps break down proteins, and it's not used as much for digestion as enzymes are. But it's important, but it's not like you really need it that much. So this is full of acid. And then what is covered all over your GI tract? What does it put out there?
Chyme?
So chyme is produced right
Mucus?
here, right? This is chyme. So chyme should be pretty acidic, right? Does that make sense? But then when it goes into here, you have an acid coming in here. Okay, just think about this. Okay, unless you're eating spicy food, but does diarrhea ever burn that much, really? Not really, right? But does throw up ever burn? It does, right? And so do you think diarrhea is very acidic? It's not, right? Unless you eat something that's really acidic, like, I don't know, like some spicy food, then it burns, right? And so when you look at this, you're gonna say that, what is this? So, what do you think is produced a lot in the small intestine?
Bicarb?
Bicarb.
Bicarb, perfect. Okay. So do you think you ever throw up stuff that comes from your small intestine?
No.
No, because of this guy, right? And it only moves that way. And so you throw up acid and you have diarrhea with a lot of bicarb, right? Okay. So throwing up, if someone was throwing up, they're getting rid of a lot of acid, right? So what kind of pH do you expect them to have?
High.
A high pH. What does that mean?
Analysis.
Okay, so if you have low this, that means you're gonna have a pH greater than 7.4, right? And so if we look at that, we can say, okay, so say the pH is 7.6. And so you're gonna tell me, so do we ever have their numbers, like, so we have CO2 and then bicarbonate,